In this video, we will see some useful application for similar triangles. In the last video, I had narrated to you what are the criteria or what are the properties that two similar triangles will have. And we had we've already explained to you, and if you have not watched, I recommend you can watch that video. I will show you very clearly how two triangles are similar. And if you have not subscribed to our channel, I recommend you to subscribe, because then it will help you to receive all our updated videos on time for you. So let's proceed to see some of the useful applications. We have seen that for two triangles to be similar, their angles will be equal. So we call that as an AAA property, where their three angles are equal. Then the second criteria is SAS criteria, where two sides and the angle in between them have similarity, which means the angles is the same and the sides which are adjacent to the angles are proportionate to each other. Then the last is SSS criteria, which is all the three sides are proportionate to each other. Alright, so now in this video, I will be going in detail explaining some of the further properties that we can derive from this similarity. The first property says a perpendicular line drawn from the vertex of a right-angled triangle divides the triangle into two triangles similar to each other and also two original triangles. So we have here this original triangle, which is A, B and C. We are drawing this line perpendicular to AC and it meets the vertex at B. And note that this is 90 degrees here and it's going to be 90 degrees here and here. Okay. Now we get three triangles, which is the original triangle ABC, which is this one. Then you have ABD, which is this one. Then you have BDC, which is this one here. Okay. Now I have drawn an imaginary line here. This is parallel to AC and it's perpendicular to BD. So I'm going to call this angle as A. So this angle is A. Then this angle will become 90 minus A, because this is 90 degrees here. And we know that this is 90 degrees. ABC is 90 degrees. So this will be A again, because it's 90 minus A. So this will be A. And your angle here will be 90 minus A, because this is again 90 degrees. Now this angle is equal to this angle because these two lines are perpendicular. So this is 90 minus A. And this angle here is A because these two lines are perpendicular. Okay. Now let's plot all these values or these angles into the triangles. So this is our A. And this is 90 degrees. And this is 90 minus A. And this is 90 minus A. This is A. This is right angled. Right angled. This is A. And this angle is 90 minus A. Alright. If you look at the three triangles now, you will find they all have three angles, which is A, 90 minus A, and a right angle. A, 90 minus A, and a right angle. A, 90 minus A, and a right angle. Since all the three angles inside are equal for all the three triangles, they are all similar to each other. Alright, let's go to the next property. It says that if two triangles are similar, then the ratio of the corresponding sides are equal to the ratio of the corresponding altitudes. So the altitudes here are AD, BE, CF. Okay, so similarly you have altitudes in this triangle. What I have done is I have taken this triangle ADC, which is inside, which is formed by the altitude here, and I have brought it here as our triangle 1, and I have brought on PSR. Use the PS is the altitude here, and I've brought it down here as another second triangle. Okay, now what are we supposed to prove? We are to prove that the ratio of the sides is equal to the ratio of the altitudes. So the ratio of the sides are AB by PQ is equal to BC by QR is equal to CA by RP is equal to AD by PS is equal to BE by QT and CF by RU. Okay, so let's cut it short. Let's find sine theta for this triangle 1. I'm sure you're familiar with sine theta by now. So triangle 1, sine theta will be equal to AD over AC, which is opposite side by hypotenuse. So I can now move this AC up and say AD is equal to AC into sine theta. Similarly, from the second triangle, I can say sine theta is equal to, opposite side will be PS over RP, and that is equal, that would imply, just like how we did for the last one, our PS is equal to RP into sine theta. Okay, if I'm going to divide AD and PS, you have AD and PS, you can see. So if I divide these two, AD and my PS, then I have to divide this also. My sine theta and sine theta will get cancelled. I will be left with AD by PS is equal to AC by RP. You can see that AD by PS is equal to, here it says CA of course, so it's the same as CA by RP. So just like how we have proved the relationship between two sides and two altitudes, we can also establish the same relationship for all of them using trigonometric ratios. The third property says, if two triangles are similar, then the ratio of the corresponding sides are equal to the ratio of the corresponding perimeters. So we know the perimeters is the sum of all the sides. So the sum of all the sides of triangle ABC over the sum of the sides of triangle DEF should be equal to the ratio of their corresponding sides. Okay, so what I would do is I'm going to call this as equal to A. AB by DE is equal to A, BC by EF is equal to A, and CA by FD equal to A. So let's see what happens. A is equal to AB by DE. So what would that mean? That is equal. That means my AB is equal to A times DE. Similarly, my A is equal to BC over EF. That implies my BC is equal to A times EF. Then A equals, let me take the third one now, CA by FD, which implies my CA is equal to A times FD. Right. Now let me add 1, 2, and 3. So I'm going to say AB plus BC plus CA is equal to, and let's put a right hand side here, A times DE plus A times EF plus A times FD. Now you can see that A is common to all the three, so we'll take the A out. A times DE plus EF plus FD. Now retain the A here, then bringing the DE plus EF plus FD to the other side, we can say A is equal to, or AB plus BC plus CA divided by DE plus EF plus FD. And we already proved that A is equal to DE by AB by DE, and A is equal to BC by EF, A is equal to CA by FT. So that proves our theorem. Property 4 says the ratio of the area of two similar triangles are equal to the ratio of the squares of their corresponding sides. Alright, so which means the ratio of the area, which is area of ABC over area of PQR, is equal to the ratio of the sides. Alright, so I think it's self-explanatory. Now let me take two sides, AC and PR, right? And I'm going to call this height here as H1, as the altitude of this triangle ABC, and H2 as the altitude of the triangle PQR. We have seen that if two triangles are similar, then the ratio of their sides is equal to the ratio of the altitude, which means if I take AC over PR, AC over PR, it's equal to H1 over H2. Alright, now let me do AC squared by PR squared will be equal to AC by PR, and that's equal times AC by PR, which will be equal to AC by PR into, I can bring the H1 and H2 here, because AC by PR is equal to H1 and H2. H1 by H2, and I multiply the numerator and denominator by a half. Alright, now look at the numerator. It's half into H1 into AC, half into H1 into AC. That's the area of this triangle ABC. And half into H2 into PR, half into H2 into PR is the area of the second triangle. Alright, so now we can say this is equal to the area of triangle ABC over the area of triangle PQR. So we have proved that our AC squared by PR squared is equal to the area of ABC over area of PQR. So the same way we can prove all of them to be equal. Now the fifth property states that if two triangles have common vertex and their bases on the same straight line, the ratio between the areas is equal to the ratio between the length of their bases. So we have to prove that the ratio between these two triangles, which is triangle BCD and triangle BDA, the ratio of their area is equal to the ratio of the base, which is AD over DC. Okay, so let's take triangle area of triangle ABD, that is equal to half into the height of ADB will be BD. Okay, so BD times the base will be AD. Half into base into height. All right. And if I'm going to divide this by the area of triangle BDC, that will be half into BD, which is the height, times CD or DC. Okay. Now can you see BD and BD will be cancelled? Half and half will be cancelled. So you're left with AD over DC. So that proves our theorem. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.